All right, hey guys, today we are going to be solving equations with fractions and decimals. And this lesson is the second day of lesson 6-1. You will need your math book, and if you want a calculator as well, and your notebook too. So make sure you have those things out and ready to go. So our learning intention for today is we are learning about solving equations, and here's how you'll know you are successful. If by the end of this lesson or this video, you can solve equations that have fractions and decimals, or could you solve an equation that looks like this or like this? Hopefully by the end of the lesson, you're able to do that. All right, so before we get started, let's see if you guys remember. Do you remember what a reciprocal is? Okay, so if I say, hey, what's the reciprocal of 1/2? Or what's the reciprocal of 3/4? Or what's the reciprocal of 2? Hopefully you know what that is. So a reciprocal is basically when I have a number and if you multiply it by something, the answer is 1. So same thing, if I do 3/4 times something, I'm going to get an answer of 1. 2 times something gives me 1. So I want you to pause the video, see if you can figure these out. All right, so the first one, a reciprocal, is basically if you take the number and flip it. So if I do 1/2 times 2 over 1, let's just kind of think about it. If I go straight across, 1 times 2 gives me 2. On the bottom, 2 times 1 also gives me 2, and 2 over 2 is the same as 1. So if you multiply two reciprocals, you get an answer of 1. Same thing with 3/4. If I times that by the reciprocal, or 4/3, I get 12 across the top, 12 across the bottom, and that equals 1. For 2, let's see if I put a 1 underneath it. Now if I flip it, I get 1/2, and now if I multiply 2 across, that equals 1. Now I want to show you guys something else that is going to help you simplify. So if I give you this problem and I say, hey, what is 3/5 times 5/3? Hopefully right away you know it's 1, but a little trick that you can use to simplify is you can look diagonally and be like, oh, 5 goes into 5 once, 5 goes into 5 once. 3 goes into 3 once, 3 goes into 3 once, and now I just have a bunch of 1s. So we're going to be using that today a little bit as we start the lesson. All right, so if you can open your math book to page 283, we're going to kind of get started there. So what we just talked about, we talked about reciprocals. They are also called multiplicative inverses, and we'll write this in your notes tomorrow when I'm back. But a multiplicative inverse is where you have, if you have 7/8 and you times it by 8/7, you get 1. So it's just kind of a way to undo multiplication. So we're going to kind of use that today as we solve equations. All right, so we're going to start on page 283. You can write anywhere on this page over on the side to have some space. So our goal is we want to try to solve this problem. Okay, so first thing, just find a little space, and I want you to write this out. So whenever you see a mixed number like this, let's change it to an improper fraction. So I'm going to do -1 and 7/8. Let's change that. So I'm going to do 8 times 1 is 8, plus 7 is 15 over 8. And it stays negative, and then there was an x by it, and then equals, let's do 4.5 as well. So if I change 4.5, I'll do 2 times 4 is 8, plus 1 is 9, 9 over 2. So your first step is if you can change those to improper fractions, that would be helpful. Now, your next step, when we were solving equations, we've been drawing our line down our equal sign. So remember, whatever you do to one side, you have to do to the other side. So you want to get this x by itself here. So I need to get rid of -15/8. Well, to get rid of that, right now it's multiplying. What you can do is you can actually multiply both sides of the equation, because it'll stay balanced, by the multiplicative inverse. So if I flip that, if I flip it to 8 over 15, still negative. If I do that on that side, I have to do the same on the other side. So let's just show you kind of why this works. Okay, now let's look on the first side, and I'll try to show you why it works. So what did we just figure out? If I do -8/15 times -15 over 8, that should be a 1. If you weren't sure, look at these 15s kind of cancel, the 8s kind of cancel, and then a negative times a negative is a positive. So I'm left with just 1x. Now on the other side, I actually need to multiply. Now we could just go straight across. I'll do this one going straight across. So 9 times -8 is -72, and then 2 times 15 is 30. Now you guys may use a calculator in this lesson. So if you want to simplify, you can grab your calculator out. You can try to think of a number that goes into 72 and 30. So if you can't, I'm just going to divide it down by 2. All right, so I'll do 72 divided by 2 first. That gives me negative 36. And 30 divided by 2 is 15. Well, I can actually divide that down by 3 again. So I'm going to divide by 3. I end up with 5. And then 36 divided by 3 is negative 12. So my final answer is negative 12 over 5. Or I can change that to a mixed number. 5 goes into 12 2 times, so negative 2, and then there's 2 left over, so negative 2 and 2/5. If you can't remember how to do that, I'll do it over here real quick. So 12 over 5 goes in there 2 times, that's 10. There's 2 left over, so 2 and 2/5, and again, it was negative. So my solution to this equation is x equals negative 2 and 2/5. So basically that means if you would plug that in up here where the x is, I'm just highlighting it in yellow, and times that out, that would make this equation true. All right, so let's try the check on the bottom of page 283 now. Okay, so first thing, go ahead and draw your line down through the equal sign. And then the first thing I notice is there's no mixed numbers, so we don't need to change these at all. Okay, so I'm gonna do that first. So that was what I would do first. Now, my goal is to get this x by itself. So I'm going to try to get rid of that negative 7/8 x. So I just want the x by itself. So I'm going to multiply by the reciprocal, or the multiplicative inverse. So I'm going to flip it and make a negative like that. All right, so now my 8, if I times that out, the 8's will cancel and the 7's will cancel. And then a negative times a negative is a positive 1x. Now remember, whatever I do to one side, I have to do to the other. So I'm going to times this by negative 8 over 7. All right, this time I'm going to show you a little trick to make it a little easier so we don't have to have such big numbers. You can always look diagonally and kind of divide these out. So I'm going to look at this diagonal. 7 goes into 7 once. It also goes into 21 3 times. Let's look at the other diagonal. 8 goes into 8 once, and it goes into 64 8 times. Now these numbers are a lot smaller. So if I times straight across, 3 times 1 is 3, and 8 times 1 is 8, and then a negative times a negative is a positive, so my answer is positive 3/8. Okay, now I want you guys to come over to the side, and we're going to do a check to see if this is right. Okay, so you're going to just maybe have to do this over on the side. So to check it, I'm going to rewrite my original equation. It says negative 7/8. Instead of an x, I'll put some parentheses, times 3/8. Hopefully that equals negative 21 over 64. So let's see if it does. All right, I'm going to grab a different color pen. So if I times across, I get negative 21. 8 times 8, 64. Those are the same exact thing on both sides, so I know I did it correctly. All right, so now let's go ahead and try to solve an equation, if you go to page 284, with a decimal coefficient. That means there's just a decimal in the front of it. So on page 284, you can just do this off to the side. Here's my equation. 0.25x equals negative 16. Okay, I'm going to draw my line down. All right, so our goal is to get the x by itself. So I want you to think about what we did when we had something like this. 2x equals 10. When we solved these, we said, hey, the opposite of multiplying by 2 is dividing by 2, because 2 divided by 2 gives me 1, or 1x. And then I divided this side by 2, and I got 5. So same thing over here. Right now I'm timesing by 0.25. So the opposite of multiplying by 0.25 is I'm going to divide by 0.25. And remember, whatever you do to one side, you have to do to the other. So on my first side, if I do 0.25 divided by 0.25, that's 1, or just 1x. And the other side, I'm going to do 16 divided by 0.25. And I get 64, and then I just need to be careful. It's negative. So my final answer is x equals negative 64. Now let's do a quick check on this. It's always good to check these. So I'm going to go to my original equation. It was 0.25 times x. Now I'm going to plug in a negative 64. Hopefully that equals negative 16. Now you guys have a calculator. So I'm just going to type in 64 times 0.25. And guess what? It's 16 and negative. And then that's what the other side says. So I did it correctly. All right, why don't you guys pause the video and try the check on page 284 and see what you get. All right, so if you do this one, again, right now it's multiplying by negative 4.7. So let's divide by negative 4.7. So you always want to kind of do the opposite operation. Okay, well, negative 4.7 divided by negative 4.7 is a positive 1K. And then if I do 10.81, I'm going to have to go to my calculator, divided by 4.7, I end up with positive 2.3. So K equals 2.3. There is my solution. Again, we can check that. We can say, okay, here's my original problem, negative 4.7 times 2.3. Does that equal negative 10.81? Well, if you were going to check it, you would type this in first. You would just times those two. So I'm grabbing my calculator. I'm checking. A negative times a positive is a negative 10.81 equals negative 10.81. My equation is balanced. If this was a scale, it would be level. So I am correct. All right, let's try one more. Example 7 on page 284. Now, again, you guys can do this off to the side, or you can just kind of watch as I do this top one. But here is the first problem. So I'm going to draw my line down. Okay, remember, our goal is to get the x by itself. So over there, I see a negative 3/10. So I'm going to think, well, how could I get rid of a negative 3/10? What if I added a positive 3/10 in? Now, whatever I do to one side, have to do to the other. So I'm going to add in 3/10 over here. Got to keep my scale balanced. All right, so over here, negative 3/10 and positive 3/10, that makes a 0 pair. So that's 0. I just have an x here. On the other side, I have to do negative 1/5 plus 3/10. Now, I can't just add that. I need a common denominator. So I know they both go into 10. So a pretty easy number to change this into. So it's times 2. Times 2 gives me negative 2/10 plus 3/10. That's just 1/10. So my final solution is x equals 1/10. Now, we're not going to check this one just for time's sake, but we'll do some checks on these tomorrow. All right, here is our last one. So I'm going to draw my line down again on the check. Why don't you guys pause this one and try it? So you want to get the m by itself. Okay, so to get this by itself, I need to get rid of that negative 5/6 over there. Well, the opposite of negative 5/6 is positive 5/6, because that will make a 0 pair. Whatever you do to one side, make sure you do to the other side. Okay, so that cancels because a negative and a positive makes 0. So I'm just left with m equals, now I need to add these up. So again, need a common denominator. Let's make it out of 6. All times 2, all times 2. I get negative 4/6 plus 5/6. Well, if I combine those, 5 plus negative 4, that will give me positive 1/6. So my answer is m equals 1/6. All right, so after this lesson, hopefully you can do the following 3 things. So kind of just ask yourself in your head, can you find a multiplicative inverse? So if I gave you the number 8/7, could you tell me what you could multiply that by to cancel it or to make 1? Could you solve an equation with a fraction? So if I gave you 2/3 x equals 10, how would you get the x by itself? And then could you solve an equation with a decimal? What if I gave you 0.24x equals 20? Could you solve that equation? So hopefully after watching these examples, you feel okay on solving equations with fractions and decimals. So now I would like you to flip your math book to page 287, and you're going to try the following problems in your math book. You're going to do number 9, 10, 12, 14, and 15. Make sure you show your work. If you're stuck, you can go ask the teacher who is subbing for you, or look back in the examples that we just did in the math book, and you can see the steps to do these. So please try these problems. I'm going to have you enter a couple of them in the video. If you finish early, now you guys can just try some other problems on page 287 to review, and then we will practice this a little bit more tomorrow when I'm back.